Basin filling stratigraphy. The Cenozoic Sonriku-Hidaka-Oki Forearc basins, basin group, are located along the NS trending zone from the northeastern offshore of the Honshu Island to the south-central part of Hokkaido, figures 2 and 3. Basin filling sedimentation in this Forearc basin group started from the latest Jurassic, and has continued until the present with several intermission events. Location maps of the Sonriku-Hidaka-Oki Forearc basins and the Jobon-Oki Forearc basins, showing the basin distributions and cross-section locations. After? Note that the basin distributions are different between the Cretaceous Paleogene Forearc and the Neogene Quaternary Forearc, since the Forearc basin type altered after the Oligocene unconformity event. Figure 4 demonstrates the Cenozoic stratigraphic correlation chart of the Hidaka-Oki Forearc basin on the northern part and the Sonriku-Oki Forearc basin on the southern part, figure 3. In figure 4, the Sonriku-Oki Forearc basin is further divided into the main part, which is mainly in the offshore territory at present, and the western basin margin part, where the Cretaceous to Paleogene stratigraphic studies are well documented, for example, using outcrop sections along the present coastline. Cenozoic stratigraphic chart of the Sonriku-Hidaka-Oki Forearc basins, showing lithostratigraphy, major depositional systems, basin filling trends and unconformity events as indicators of background plate tectonic history. Compiled after refs. The Cenozoic sedimentation both in the Hidaka-Oki and Sonriku-Oki Forearc basins began at around the late Paleocene time after the KT gap unconformity event, and continued until the interruption by the large-scale Oligocene unconformity formation event, figure 4. Overall depositional systems in this stratigraphic interval between KT gap and were coal-bearing fluvial systems with cyclic intercalations of bay estuarine systems in response to relative sea level changes, figure 4. The detailed sedimentological basin analysis revealed that the depositional settings must have been in a restricted environment sheltered from an open marine condition, as shown in figure 5. This Forearc setting can be categorized as the shelved, bench type in these Forearc basin classification scheme, in which the trench slope break ridge is uplifted and the basin inside is overfilled with bay to fluvial sediments. Thus, the Cretaceous to Paleogene Forearc basins in the Sonriku-Hidaka-Oki Forearc basins are characterized as such trench slope break uplifted, overfilled configuration with aggradational coal-bearing bay to fluvial sediments. Schematic and conceptual Forearc setting model for the Sonriku-Hidaka-Oki Forearc basins. This setting can be categorized as the shelved, bench type of Forearc basin classification. After the formation of both the Hidaka-Oki and Sonriku-Oki Forearc basins started drowning due to a wide-scale, tectonic hinge-type subsidence commencement, figure 6, possibly related to the onset of tectonic erosion at the plate subduction zone along the Ni-Japan Arc. This event resulted in the transformation of the Forearc basin type from the shelved, bench type to the slope type of scheme. The unconformity surface was overlain by a transgressive succession, which was further followed by deeper marine muddy facies predominant over the Neogene and Quaternary successions in the Sonriku-Oki Forearc basin, although short-term episodes of unconformities, Miocene unconformity and Quaternary unconformity, took place at around early Miocene and the earliest Quaternary, figure 4. On the contrary, the Hidaka-Oki basin experienced the conversion from a Forearc to foreland basin after the Monk Formation due to the westward collision of the Hidaka block associated with the coral Forearc sliver migration, figure 6. The deeper part of the foreland basin was filled with submarine fan turbidites, which were derived from the uplifted Hidaka block, figure 4. The basin filling succession as a whole demonstrates an aggradational to upward shallowing succession, resulting in the shelfal to shallow marine facies in the uppermost part, figure 4. Cartoons showing the basin evolution and transformation of the Sonriku-Hidaka-Oki Forearc basins. The event caused the transformation of the basin type from a benched, overfilled fluvial-dominated Forearc to a sloped deeper marine Forearc. The Hidaka-Oki basin experienced further conversion to a foreland basin due to the Hidaka block collision,